Hello viewers, we shall continue our discussion on TCP/IP. In the last lecture, we have covered some of the issues of TCP/IP, particularly the network layer protocols and some lower layer protocols. In this lecture, we shall consider the transport layer protocols and also some of the application layer protocols. And here is the outline of today's talk. First, I shall give a brief introduction which will put you in perspective of the need for UDP and TCP, that means the transport layer protocols. And we shall introduce two transport layer protocols. One is user datagram protocol known as UDP in short, another is transmission control protocol TCP. As we shall see, UDP is a connectionless, unreliable datagram service. On the other hand, TCP is a connection oriented service and it provides you reliability with the help of flow control, error control and congestion control, which I shall discuss in detail in this lecture. Then we shall see how the communication take place using the TCP/IP based on client server paradigm and some applications which work based on client server paradigm such as domain name system, remote login, then mail transfer, file transfer. We shall briefly discuss about them. And on completion of this lecture, the students will be able to explain how UDP allows two applications running into remote locations can communicate. And they will be able to also state the limitations of UDP because it is not connection oriented, it is unreliable. Because of that, it has got some limitations. So the students will be able to state that or identify that. Then they will be able to explain TCP, how TCP provides connected oriented service, the mechanism behind it, and they will be able to explain how TCP incorporates reliability in internet communication. Then we shall discuss, then they will be able to explain how DNS, domain name system, allows the use of symbolic names instead of IP address, which we have introduced in detail in the last lecture. The students will be also able to explain the use of client server model for remote login, mail transfer and file transfer. And this client server model is the basis of any distributed algorithms. So, here is the introduction to put you in perspective. If you look from user's point of view, you will find that TCP/IP based internet is nothing but a set of application programs that use the internet to carry out useful communication tasks. So, a number of applications are running, and how TCP/IP uses the underlying network for that is one view of the user. And particularly the most popular internet applications that we use in our day-to-day life are electronic mail, file transfer, remote login. How these applications run using TCP/IP, that will be introduced in this lecture. We have seen that Internet protocol allows transfer of IP datagrams among a number of stations, where the datagram is routed through the internet based on IP address of the destination. So, we have seen in the last lecture the Internet protocol allows communication between two computers or two hosts, and that is done with the help of the IP address. However, an additional mechanism is needed to facilitate multiple application programs which are known as processes. What is a process? A process is nothing but a program in execution. So, an application program in execution is called an process, and how two processes can communicate in different stations with each other simultaneously, that is the need for this TCP. That means a particular host may be running a number of processes. As we know, in a multi user environment, multiple processes will be running simultaneously, and how multiple processes can communicate simultaneously through the internet, that will be discussed and how it is done using the transport layer protocol. We have already discussed the relationship of the TCP/IP model with the OSI model, and in the last lecture we have already discussed some of the aspects of this part, that means the network layer protocols, the internet protocol, along with the companion protocols like ARP, RFRP, ICMP and IGMP we have discussed in detail, and we have briefly mentioned about this SLEEP and PPP also, which were not covered earlier. Now in this lecture we shall discuss first the UDP, then TCP, and we shall also discuss some of the applications, because ultimately the users are interested in applications, and of course the TCP/IP is the underlying protocols which are being used for that purpose. So first let us focus on the simplest of the protocols, the user datagram protocol, or UDP in short. So UDP provides the primary mechanism that application programs use to send datagrams to other application programs. So suppose an application program is running in host A, and it will send the message to the one of the two transport layer protocol, either TCP or UDP. In this particular case we are considering UDP, and that UDP puts a header, and that segment is sent, and that goes to the IP layer, and IP layer converts it into a datagram by adding a header, and that datagram goes to the data link layer, which makes a frame by putting a separate header and a teller, and that frame is transmitted bit by bit through the physical layer, and that goes to the other side through the internet. And at the other end, as it reaches the destination host, then it goes off through the data link layer, IP layer, and headers and tailors are removed. Ultimately the message is delivered to the application of the host B. So this is how the communication takes place with the help of the UDP. Now as I was mentioning that multiple processes can be running in a single host, and that requires what is known as multiplexing and demultiplexing. So multiple hosts will be running, and they communicate with using a concept known as port mechanism. So UDP is responsible for differentiating among multiple sources and destinations within one host. So what is happening, you have got a single host and multiple applications are running, and each application is associated with a port number. So each applications transfers messages through different ports and gives it to the UDP, and UDP segment is then passed on to the IP. So here what we are doing is known as multiplexing. Similarly, the datagrams will be coming to the IP layer, which will forward to UDP, and UDP will identify different applications based on port numbers, and it will do the demultiplexing and send it to the respective applications based on suitable port numbers. So here we are using another address, you can say, which is port number. We have already discussed about the two types of addresses. The physical address, that physical address is being used by the data link layer. For example, in the local area networks we use the physical layer address, and as we know that physical layer address is 48 bit, that Ethernet address. On the other hand, the internet address, that IP address, is from host to host, that is 32 bit address, as we have discussed in the last lecture. Now as you can see, there are port addresses which are essentially identified as processes. So it is for process to process communication, which is 16 bit. So we have now three different types of addresses to be used in TCP/IP: the physical address, internet address, and port address. So, here is the UP datagram format, UDP datagram format. As you can see, it has got a source port and destination port, and this gives you the, that source port gives you the, defines the port number of the application program in the host of the sender. That means sender may be running a number of applications. So, that a particular port number gives you the source from which application it has come, that particular datagram has come. Similarly, the destination port number is it defines the port number of the application program in the host of the receiver. So, we see that with the help of this we are doing demultiplexing, and with the help of the source address we are doing multiplexing. And this length field, it provides a count of octets in the UDP datagram, and as you can see minimum length is 8 octets, which is essentially the header of the UDP. As I mentioned, that UDP is a unreliable protocol. So, essentially there is no need for error detection. So, that is why the error detection is optional in case of UDP. So, whenever it is not used, this is made 0. So, 0 is written here in this checksum field, and of course, when it is being used, there are situations where it is being used, in such case it is not 0. As I mentioned, the transport layer addresses are specified by 16-bit port numbers. So, internet there is a, these port numbers are assigned with the help of an agency known as Internet Assigned Number Authority, IANA, and the addresses are divided in 3 ranges, in 3 categories. One is known as well known ports. So, you can say this is the range, you can say it is divided into 3 parts, 0 to 1023. This part is known as well known ports, and these well known ports are controlled by IANA, that Internet Assigned Number Authority. On the other hand, 1024 to 49151, so up to this, say 49151, this is actually this is your well known ports, these are registered ports. So, these registered ports, for to use these ports one has to register with the IANA. So, these are not well known ports. So, for to use any of these addresses, one needs to register with IANA. On the other hand, there are other ports starting from say 49152 to 65535, that is what can be used by using a 16-bit address. So, with the help of the 16-bit address, this is the maximum number one can use, and these numbers can be dynamically assigned by the user as and when needed. So, for this neither it is necessary, it is not necessary to register with IANA, and also it is not necessary to use the well known ports. So, these are user can use use them dynamically in different case situations. So, these are the 3 different categories of port addresses that are commonly used, and here are the well known ports used by UDP. So, there are some port numbers which are provided as well known ports. For example, port number 7 is used for the purpose of echo. Sometimes we do the ping operation, as you know. So, that is being performed with the help of this port number. Then there are other applications like SNMP, Simple Network Management Protocol, and some special port number is assigned. So, we find here are these are the common well known ports used by UDP given here for different applications. So, we are not discussing them in detail. Let us now focus on the characteristics of UDP. We have seen that UDP provides an unreliable connectionless delivery service using IP to transport messages between 2 processes. Because it is unreliable and it is connectionless, the outcome is the messages can be lost, duplicated, delayed, and can be delivered out of order. So, if a packet is lost, the sender will not know about it. If a packet is damaged, the receiver will not know that a datagram has been received in error condition. It has become corrupted. Similarly, since the datagrams can pass through different paths, different routes, they can reach in out of order. So, at the receiving end they have to be put in order, and so these are the limitations of the user datagram protocol. However, UDP is a very thin protocol, as you have seen. It has got only 8 byte header, 8 octet header. As a consequence, it does not it is not having any high overhead. Overhead is much less in this particular case. However, it does not add significantly to the functionality of IP. We have seen that IP provides you also the connectionless service. However, it provides you from host to host. Only additional feature that UDP adds is from process to process rather than from host to host. That is the only thing that is being provided. And also it cannot provide reliable stream transport service which is needed in many applications. And for many applications, reliability or reliable communication is the key, or is very important. So, in such a case we have to look for another protocol, or we have to use another protocol which is known as transmission control protocol, or TCP. So, TCP provides a connection oriented, full duplex, reliable stream delivery service using IP to transport messages between two processes. So, we are in both cases IP is being used to transport messages between two hosts, and then with the help of the port address it is communicated between two processes. And the reliability is ensured because of connection oriented service, because of flow control used in TCP, and it uses the sliding window protocol, which we have already discussed in detail. By using, we know that by using sliding window protocol you can do flow control. So, that is being performed here. It does error detection using checksum, and also it uses error control using go back and ARQ technique. So, it performs error control as well. Moreover, it also performs congestion control by using congestion avoidance algorithms such as multiplicative decrease and slow start, which we shall discuss later on. Now, let us have a look at the TCP frame. Obviously, the TCP frame is not very thin. It has got 20 octets. So, the source port, destination port. Apart from the source port and destination port addresses, each of them are of 16 bit. There are additional fields such as sequence number, acknowledgement number, data offset, reserved, some bits are reserved, and several flag bits, 6 flag bits, and there is a window which is used for flow control. Then there is checksum which is used for error detection. Then there is a urgent pointer which is used in some situations, and there is then you have got the optional field plus padding. So, apart from header you have got the optional field and padding and some, then comes the data. Let us look at the function of different fields. Source port as usual defines the port number of the application program in the host of the sender. Destination port is defines the port number of the application program in the host of the receiver. Then the sequence number conveys the receiving host which octet in this sequence comprises the first byte of the segment. So, we see the counting is done with the help of octets or bytes in terms of bytes. So, the sequence number is specified in terms of the byte number, and the octet with which the segment starts. Then the acknowledgement number, this specifies again the sequence number of the next octet that receiver expects to receive, and in both cases 32-bit fields are used. Then you have got header length, which is 4-bit. This field specifies the number of 32-bit words present in the TCP header. So, with the help of this 4-bit field, the number of 32-bit words in the, as you have seen, number of 32 words can be 1, 2, 3, 4, 5, or it can be more, or it can go up to 20 octets. So, and it specifies in terms of the 32-bit words. Then, as I mentioned, there are several control flag bits. First one is URG, stands for urgent pointer, and urgent pointer is used in some specific situation. Then there is a acknowledgement flag bit, which indicates whether acknowledgement field is valid. So, if this bit is not 1, then acknowledgement field is invalid or is not used. Then PSH stands for push the data without buffering. So, in such a case, a special situation where pushing of data has to be used without buffering. Then RST, reset the connection, as we shall see, this flag bit is used when connection establishment is done. Then SYN, synchronize sequence number during the connection establishment. So, synchronize or SYN flag bit is used at the time of connection establishment. FIN, which stands for finished, which terminates which is used for terminating a connection. Then there is a 16-bit window which specifies the size of the window, that is the buffer size available, and the checksum, that is 16-bit checksum is used. As we have already discussed how the checksum can be calculated by using that ones complement addition, all in terms of 16 bits and then complementing it. And then there is a user pointer which is used only when URG flag is valid. So, when the URG flag is valid, then this particular pointer is being used, and there are optional 40 byte information can be provided if necessary. So, the TCP also has got a number of well known ports. As you can see, port number 7 is used for echo, 9 for discard, and as we shall see, there are several other applications like Telnet has got a well known port, which is used, this Telnet is used for remote login. Then SMTP, simple mail transfer protocol, which is used for mail transfer. This has got the well known port number 25. Domain name server, which we shall discuss, has got a well known port number 53, and HTTP, which is used for hypertext transfer protocol, has got well known port number 80, and so on. So, we see the important applications which are being used with the help of TCP IP is provided with well known port numbers. Now, let us focus on the connection oriented service. As I mentioned, the TCP establishes a virtual path between the source and destination processes before any application can run. So, there are two processes involved. One is connection establishment, which to start the connection, which is used to start the connection reliably, and the connection termination, with the help of which the connection is terminated gracefully. These two are being used, and as I mentioned, communication is full duplex, and for connection establishment, a three-way handshake protocol is being used. Let us first discuss that. So, to establish a connection, as I mentioned, that SYN, that's sync flag bit, is set, and then sequence number is set to some value x, and if here you are sending one datagram to the other host, to the host on the other side. In response to that, the host on the other side will send an acknowledgement. That acknowledgement will have a sync bit set, and it will provide you the sequence number y and acknowledgement number x plus 1. You can see it is using one sequence number x, that means the next datagram that is expected will start with x plus 1 byte or octet. So this is being used when the host is ready for sending data. Whenever it is not ready, as I mentioned, there is a possibility that a particular that port number is being busy for some other application. In such a case, connection cannot be established. In such a case, instead of sync datagram, that RST flag bit is set and RST packet is being sent from the host 2 to host 1, or so that means the connection cannot be established. Now, however, when the host 2 is ready for establishing connection, then this particular frame is being sent, packet is sent to the other side, and in response to that, the host 1 will send another sync packet, and which will with sequence number x plus 1. Earlier it was x, now it is x plus 1, and acknowledgement number y plus 1. So you see the sequence number was y here. So 1 byte is being used for the purpose of establishment of synchronization, and acknowledgement number y means that this host 1 is also ready to receive packet starting with y plus 1 as the beginning of the that packet. Now, this is how the three-way protocol is being used to establish a connection. Now, for connection termination, a four-way handshaking protocol is necessary for termination of connection in both directions. For the termination purpose, as I mentioned, it is a full duplex protocol. However, we may consider it as two half duplex or two simplex connections. That means two connections can be terminated independently. So, for example, if host wants to terminate the connection for sending data from this end to the other end, then it will send one packet, that datagram with FIN or finished flag bit set with sequence number x, and on receiving this, the host 2 will send an acknowledgement packet with SEK is equal to x plus 1. So, this is when this is being received, that means this connection which is used for sending data from host A to host B is terminated. However, the data transfer in the other direction from host B, host 2 to host 1 can continue, and if host 2 wants to terminate that, host 2 again sends another packet with datagram or packet with finished flag bit set with sequence number y and acknowledgement x plus 1, and on receiving that, the host 1 sends an acknowledgement packet with SEK is equal to y plus 1. Now, whenever both the ends wants to terminate connection, these two can be combined to a single packet. That means both acknowledgement flag bit and FIN flag bit can be set, and by doing that, as you can see, SEK part, that acknowledgement field is same x plus 1. Only these two flag bits are to be sent, and instead of two signals, only one message will go from host 2 to host 1, and that way it can become a three-way protocol to terminate connection when both the connections are to be terminated simultaneously. Now, let us focus on the reliability. As I mentioned, reliability is ensured by flow control, error control and congestion control. Now, flow control is being done with the help of a buffer. So, whenever that sender is sending data, it sends the size of the data, that means 4K is the size of the data, and starts with the sequence number 0. So, and as it reaches the receiver, then 4K buffer gets filled up, as you can see this part gets filled up, and it sends an acknowledgement with 4096. So, that is the beginning of the sequence number which the receiver is expecting, and window size 4096 because 4K window is now free. So, that is being mentioned here, that window available is 4K. Now, if the sender has a 3 kilobyte data to send, then it can send it starting with sequence number which is the beginning of the octet 4096, and as it reaches the destination, as you can see, so 4 plus 3 7 kilobytes of buffer gets filled up. Now, it sends an acknowledgement with acknowledgement field 7168, that is the beginning of the sequence, and window size 1K because this is the window size available at the receiving end. If the sender has more data to send, it will not be able to send, it will not be able to send now because buffer is not available here. Now, the application program can read the data and transfer it maybe to the secondary storage. In such a case, the buffer will be empty and the buffer will be free, and after the suppose the application reads 4K bytes, these 4K bytes are read by the application. So, now the 5K buffer becomes empty. So, window size becomes 5120 and it sends an acknowledgement frame to the sender, and on receiving that the sender can send another 4 kilobyte of segment with starting with sequence number 7168. So, this is how the flow control is being performed and the buffer size is communicated by the receiver as whenever an acknowledgement acknowledgement segment is sent from the receiver to the sender. So, this is how the flow control is being performed. Let us see how error control is being performed. To perform error control, a number of timers are used. There are 4 timers. One is retransmission timer, second one is persistence timer, third one is keep alive timer, fourth one is time weighted timer. So, retransmission timer is used to in situations, suppose a frame has been sent and it is lost. So, the whenever that retransmission timer is started, and whenever the timeout occurs and if acknowledgement does not come, then that frame is retransmitted. So, the retransmission timer is used for the purpose of retransmission whenever a frame is lost. Then the persistence timer is used to avoid some kind of deadlock. We have seen that let us consider this situation. Say the buffer is now empty, is not enough, only 1K, and a frame has been sent and a segment has been acknowledgement has been sent by the receiver. Now, on receiving this, the sender is waiting for acknowledgement having a higher window size. Now, another acknowledgement sent only when this buffer becomes empty with window size 5190. Now, suppose this particular frame is acknowledgement is lost. So, what will happen? The sender will be waiting for the acknowledgement, the receiver will be waiting for the data. So, this leads to some kind of deadlock, and this deadlock can be avoided with the help of this persistence timer. So, persistence timer, whenever a timeout occurs, it will send a frame, it will send the that sender will send a persistence segment to the receiver, and on receiving that, this particular acknowledgement will be again sent by the receiver and data communication will start. Then keep alive timer is used in situations where the communication is not taking place for a long time. Suppose a receiver, a sender has no data to send for a long time. So, in such a case, what can happen when the data communication is not taking place for a long time, then the transmitter may assume that the receiver has now been turned off. So, to know that a keep alive frame is being sent by the sender, and if the receiver responds, then the connection is continued, otherwise the connection is terminated, and time weighted timer is being used at the time of termination. So, time weighted terminator is used at the time of termination. Whenever termination is going on, whenever the termination is performed, immediately say termination is performed, but the connection is kept open for two packet transmission time, 2 RTT, that is your receive transmission, the transmission time 2 into the round trip time. This is the round trip time. So, for 2 round trip time, this timer waits before the connections are shut off. Now, let us focus on the congestion avoidance algorithm. So, congestion avoidance is performed by using congestion is avoided by using 2 algorithms. One is multiplicative decrease and another is slow start. As you can see in the beginning, there are 2 reasons for any congestion control. One is your receiver capacity, there are 2 reasons for congestion. One is because of the smaller receiver capacity, another is because of lower network capacity. And as we have seen, the receiver capacity is being is provided with the help of the window. So, window size provides the receiver capacity. However, the network capacity is not available, is not provided by this window. For that purpose, a separate window known as congestion window is used, and that the minimum of the 2 is used for sending data. So, initially suppose 1K is the 1K word is the segment size that is being allowed by the network. So, initially one segment is the segment 1 is being sent, and if no timeout occurs, then the 2 segments are sent, then 4 segments are sent, then 8 segments are sent, then it increases exponentially until that threshold is being reached. There is a threshold which is decided by the congestion window, and after that threshold it increases linearly. That means it is incremented by 1K, 1K and so on. So, initially it is 1K, then 2K, then 4K, like that exponentially it increases, and after the threshold is reached, it increases linearly, and whenever timeout occurs, then this threshold is halved. Whatever was the value here, half of that is considered as the threshold, and then again that slow start is being performed, and then multiplicative decrease is being performed. So, this is how the congestion avoidance is performed with the help of multiplicative decrease and slow start. There is another problem here, that retransmission time. Question arises, how do you find out the retransmission time? Timeout, for how do you decide the retransmission time? There is another issue here in connection with that retransmission time. In case of internet, the probability of timeout varies. I mean, it is over a large space, large time period. In case of LAN, it can be very small, that delay can be very small, but the delay can vary over a large range in case of internet. So, if you choose a retransmission time T1, then there will be many retransmissions, that retransmission time at time T1, that there will be many retransmission. On the other hand, if you choose T2 as the retransmission time, then there can be then unnecessarily you are wasting time. Now, what is being done? Initially a suitable value is chosen based on the exact value based on the measurement. What is the round trip delay time? Based on that, a retransmission timer is set, and after that if there is no timeout, then this timer is increased, and on the other hand if there is timeout, then it is decreased. So, in this way the retransmission timer is controlled, in variable RTT is being used. Retransmission timer is used and based on the best current estimate of the timer. So, we have discussed how the flow control and congestion control is being performed. Now, let us focus on the client server paradigm that is being used for various applications. As we shall see, the way the application programs communicate with each other is based on client server model. In fact, as I mentioned, this provides the foundation on which distributed algorithms are developed. As we shall see, in the present day context, many algorithms are distributed algorithms, and all the distributed algorithms are work based on the client server model or client server paradigm. So, let us focus on the discussion of client server paradigm and discuss how exactly it works. So, you have got a client process which formulates a request. So, you have got two systems, one is client, another is server. So, a client runs a process which formulates a request, sends it to the server and then awaits the response. On the other side, the server process awaits a request. So, it is not just sleeping, it is waiting for a request, and at a well known port. Obviously, it is waiting for request at some well known ports, as I have already mentioned, and then after receiving that it sends responses. So, the server process awaits a request at a well known port that has been reserved for different applications for the service, and then sends response. So, this is how it works, and this through the internet the communication takes place based on TCP/IP. Of course, the communication is full duplex, as I mentioned. The both client and server communicates with each other by using full duplex communication. And to do that, there are two identifiers. One is your IP address, another is your port address. So, two information is necessary for process to process communication. Just the IP address cannot serve the purpose. Apart from IP address, it is necessary to have the port address, and these two together are known as socket address. So, a socket address comprises two components. One is your IP address and another is your socket address, and these two together gives you the I mean these two, so not sorry not it is not socket address, it is port address. So, it is essentially IP address and port address. These two together forms the socket address, and a pair of socket addresses, one at the client and the other at the server, are necessary for transport layer protocol. So, that means at the client side you will have a socket address, and at the server side another socket address will be necessary for communication between the two. So, this allows multiplexing and demultiplexing by the transport layer. That means, the socket address is used for multiplexing and demultiplexing by the transport layer with the help of IP address and port address. So, the IP address is provided by the IP header, port address is provided by the TCP header or UDP header, whatever it may be. Now, let us focus on some applications which work using the client server paradigm. The one very important application protocol is known as domain name system. We have seen that IP addresses are convenient and compact way of identifying machines are fundamental to the. So, IP addresses are used for communication between two hosts. However, it is unsuitable for human user. So, human user cannot really remember a long sequence of zeros and ones, although by using dotted decimal notation it has been made slightly user friendly, but it is not enough. So, it is necessary to use high level symbolic names for convenience of the humans. And this domain name system application software permits users to use symbolic names, but the underlying network protocols require addresses. So, that means the IP, the TCP/IP protocol, the IP requires IP address, that means the machines require IP address, users require symbolic address. So, the gap has to be bridged, and that is being done by using the domain name system, and that requires a suitable syntax and also an efficient translation mechanism. And there are two ways of providing names. One is known as two ways of providing address. One is known as hierarchical naming system, another is flat addressing system. So, the DNS uses hierarchical naming system, as we shall see, and how it is being done we shall explain. And before that, let us briefly discuss about the flat namespace. In this case, each machine is provided with a unique name as assigned by the NIC, Network Information Center, and a special file is used to keep name address mapping, and all hosts must know the current mapping from all other hosts with which they want to communicate. So, this requires large mapping file if communication with a large number of machines is required, particularly in the present day internet context. The size of the number of people that is being communicating with each other is very, very large. So, this will require a huge mapping file. So, it is not really a good thing for communicating to arbitrary machine over a large network such as internet. So, this flat namespace which was used earlier is not really suitable, and for that reason hierarchical namespace has been used, which break complete namespace into domains. So, instead of providing a unique name, it is divided into a number of domains. So, domains are domains broken up recursively into one or more subdomains. So, each domain is divided into a number of subdomains, each of which basically a domain name again. So, further division to create any level of hierarchy is being provided with the help of the namespace tree, and it delegates the task of name allocation resolution parts of the tree to distributed name servers. So, that translation from name to address and address to name is performed in a distributed manner, as we shall discuss. So, this is how the domain names are given in a hierarchical manner. As you can see, there are two flavors of naming systems. One is based generic, another is based on country. Generic is say COM, which are assigned to communication companies, EDU for educational institutions, ORG for different organizations like IEEE, GOV government for government organizations, NET for network companies. On the other hand, AU for Australia, IN for India, US for USA, it is based on the country names. So, this is your root domain, and under the root domain you have got several subdomains. It can be based on generic or country based. So, you have got a number of subdomains, and under each subdomain again you have got several subdomains. For example, under India IN subdomain you have got ERNet, VSNL and so on. So, under ERNet again you can have different IITs like IITM, IITK, IIT KGP, IITB and so on. And then under IIT KGP you have got CC, CAC, mechanical. So, you can see it starts with a root node, and then you have got next layer of domains, and then another layer of domains. In this way it can continue, and ultimately a name will be For example, a name can be like CSE dot IIT KGP dot ERNet dot N. That forms a name, and any user connected to this server can be, say, it can be APAL at CSE. So, this forms the complete name for sending any email or other things. And the translation of a domain name into equivalent IP address is called name resolution, and it is very efficient because of the use of distributed databases, and the databases are stored in different servers, which is distributed among distributed. As you can see, some of the databases are stored in server, some of the databases are stored in ERNet server, some of the databases are stored in IIT KGP servers, some of the databases are stored in CSE server, and so on. And the mapping is being performed in this way by using recursive query resolution. So, the client sends the query to the next server. So, CSE IIT KGP ERNet in, then it sends to the next server IIT KGP ERNet in, that query goes to the next hired domain, then it goes to the ERNet in, then it goes to the in, and it goes again to the edu, and if the information is not available there, that then it goes to the UCF edu, and it goes to CS UCF edu, and it definitely has the record, and it sends the IP address and goes back to the client. So, this is how the query is resolved. That means the name is mapped to address. So, name to address mapping is performed in this manner. And here are some of the applications based on the client server protocol. The telnet is used for sending emails. It is telnet is used for remote terminal protocol. There are three basic services offered by telnet. It defines a network virtual terminal that provides a standard interface to remote systems. So, any key press goes to the remote system, and also the response is displayed on the user system. So, in this way, client systems. In this way, the communication as if a computer is directly connected to a remote server. So, a client can be connected to a remote server. This is how it works. That it includes a mechanism that allows the client and server to negotiate options from standard set. It treats both ends symmetrically. That means client to server communication is performed in a symmetric manner. Similarly, the file transfer protocol is another protocol that uses the client server paradigm, and this is being used to transfer files between two remote machines through internet. A TCP connection is set up before the transfer, and it persists throughout the session. As you can see, through the internet, the files can be transferred from the client, from the server, it can go to the client, and for that purpose two connections are necessary. One is control connection, another is data connection, and more than file can be sent before disconnecting the link. User views FTP as an interactive system because file transfer can be done in an interactive manner with the help of this control connection, and then data transfer is performed with the help of this data connection. Finally, electronic mail is among the most widely used available application services. The mail system buffers outgoing and incoming messages, allowing transfer to take place in the background. So, some kind of mail gateway can be used, and the protocol that is being used is known as SMTP. The TCP/IP protocol that supports the electronic mail on the internet is called Simple Mail Transfer Protocol, which supports the following: sending a message to one or more recipients, sending messages that include text, voice, video and graphics, and this is the basic system. So, you have got a client and here you have got a server, and that server holds the messages that can be sent through the internet using TCP/IP to another server, mail server, and that mail server is connected to another clients, and these two clients communicate with each other through these servers which act as the gateways. So, with this we come to the end of the discussion on TCP/IP. Here are the review questions. First question is, what is the main function of UDP protocol? Why pseudo header is added in a UDP datagram? Third question is, how TCP establishes and terminates connection? Fourth is, what are the advantages of DNS? And fifth question is, explain how FTP works. Answer to the question number 1 is, why do you need ARP protocol? Answer is, two machines on a network can communicate only if they know each other's physical address. So, IP address is not enough to deliver the packets. So, you have to perform mapping from IP address to physical address, that is being performed by ARP protocol, as we have discussed in detail in the last lecture. Second question was, what is the purpose of dotted decimal representation? Give the dotted decimal representation of the IP address this. So, as you know, the 32-bit field is divided into 4 octets, and each is represented in a decimal form, and that gives the IP address in dotted decimal notation, and for this bit sequence this is the dotted decimal notation. Third question was, how is masking is related to subnetting? Masking is the process of extracts the physical network address part from the 32-bit IP address. When subnetting is done, the masking is performed to get the subnetwork address rather than the network address. So, 3 levels of hierarchy is being used, as we have discussed. Fourth question was, what limitations sleep protocol are overcome in PPP protocol? Limitations of sleep which are overcome by PPP are, no error detection correction is supported, IP addresses should be known in advance, supports only IP, no authentication, no standard, and this is being overcome by using PPP protocol. Fifth question was, what are the key features of IPv6? As I mentioned, some of the most important new features are mentioned below. It uses 128-bit address, it uses more flexible header format, and there are 2 parts, basic header followed by extended header, and resource allocation options are not present in IP version 4. Provision for new and future protocol options are provided. It supports security facility for authentication, and the fragmentation is done at source. So, these are the features of IPv6, and with this we come to the end of our discussion on TCP/IP. Thank you.